Diodes. A semiconductor diode is a two-terminal electronic component that primarily allows the flow of electric current in one direction while blocking it in the opposite direction. They are fundamental building blocks in modern electronic circuits and are widely used for various purposes. Here are some key aspects of semiconductor diodes. Basic structure. A semiconductor diode typically consists of two semiconductor materials joined together, forming a p-n junction. The p region, positive, contains excess holes, while the n region, negative, contains excess electrons. Forward bias. When a positive voltage, higher potential, is applied to the p region and a negative voltage, lower potential, is applied to the n region, the diode is said to be forward biased. In this condition, the diode allows current to flow easily through it. Electrons from the n side move towards the p side, and holes from the p side move towards the n side. Reverse bias. When a positive voltage is applied to the n region and a negative voltage is applied to the p region, the diode is in reverse bias. In this condition, the diode blocks the flow of current, except for a small leakage current. This is because the electric field at the junction acts as a barrier to the movement of charge carriers. Forward voltage drop. Forward bias voltage. In the forward bias condition, there is a voltage drop across the diode, typically around 0.7 volts for silicon diodes and around 0.3 volts for germanium diodes. This voltage drop is known as the forward voltage drop or threshold voltage. Reverse breakdown voltage. In reverse bias, a diode can withstand a certain reverse voltage without allowing significant reverse current to flow. Beyond this voltage, called the reverse breakdown voltage, the diode breaks down and allows a substantial reverse current. There are two types of breakdown. Zener breakdown. This is a controlled breakdown, often used in Zener diodes to maintain a constant voltage across the diode. Avalanche breakdown. This is an uncontrolled breakdown that occurs at higher reverse voltages and is used in avalanche diodes. Applications. Diodes have numerous applications, including rectification, converting AC to DC, signal clipping, voltage regulation, protection against reverse voltage, and signal demodulation. Light-emitting diodes, LEDs, are a type of diode that emits light when forward biased and are used in displays, indicators, and lighting. Diode characteristics. Diodes exhibit exponential current voltage, IV, characteristics. The current through a diode increases exponentially with the forward bias voltage. Ideal versus real diodes. Ideal diodes have zero resistance in the forward direction and infinite resistance in reverse. Real diodes have small but finite resistance in both directions. Understanding the behavior and characteristics of semiconductor diodes is essential for designing and analyzing electronic circuits. They are fundamental components in a wide range of electronic devices and systems. Energy bands in solids. In solids, electrons exist in energy bands. The two most important bands are the valence band, lower energy, filled with electrons, and the conduction band, higher energy, empty or partially filled. The energy gap between them is called the band gap. Intrinsic and extrinsic semiconductors. Intrinsic semiconductors have a pure crystal structure and, at absolute zero temperature, have a completely filled valence band and an empty conduction band. Examples include pure silicon Si and germanium Ge. Extrinsic semiconductors are doped with specific impurities to increase their electrical conductivity. N-type semiconductors have added electrons, example phosphorus, while p-type semiconductors have added holes, example boron. Hall effect. The Hall effect is the generation of a voltage difference, Hall voltage, across a conductor when a magnetic field is applied perpendicular to the current flow. This effect is used to measure the strength of magnetic fields and to determine the type and concentration of charge carriers in a material. P-n junction diode.